Hello, my friends. Welcome back to BIMvoice. Today, we are continuing the discussion with Vlasceanu from PORR, Romania, and I'm really looking forward to this to see how he's using practically BIM and innovative technologies at his work and on his projects. Hi, Dan. Nice to have you again.
Hello, Petru. Thanks for having me again. And because yesterday was, I don't know if your viewers know, the Romanian national holiday, I just want to say happy birthday for us.
Yeah, happy 1st December. Okay, let's go ahead. What are you going to show me today?
Okay, so again, thank you again for having me. And I was looking forward very much for this part 2 and maybe 3. Because this is the actual part where I get to push the buttons and explain exactly what I'm doing at work. First of all, I will start by explaining the CDE, the Common Data Environment we use. And then from there, I will present the different use cases we have here for in Romania. First of all, I wanted to say that I'm not sure how people, your viewers, approach a BIM project or how it was done classically in other countries, but here in Romania, most of the projects, the classical ways of doing things is you have a server. It's usually set up by the IT department, and then they give access to people, and everybody feeds information, files there, PDFs, DWGs, whatever. The problem with working like that, in my opinion, is you do not really have a control of the history of the files. If there's a revision or something, a change to the project, normally what the people do, they put an underline revision 78, whatever, something like that. You do not have control or all of the documents stored in the same place. They are just replacing it with the new one. But anyway, this was just a brief history of how projects, at least at my company, are being dealt with in a classical way. And we at the innovation department are kind of trying to change that and disrupt the workflow a little bit. Okay, so the CDE we have chosen to use is Trimble Connect. I know that also you have experience with this common data environment.
Yes.
This was mostly set up because we already use a lot of Trimble equipment on site. And when we did the first pilot project, the idea for the CDE was a combination between Trimble Connect and Quadri, actually. So I've worked, and I am still working in Quadri, but I think it's me and one other person that were working in Quadri. It is, in my opinion, one of the best CDEs available on the market, Quadri, but
for infrastructure.
Yeah, sorry. I'm talking.
No, it's fine. No problem.
in my head, all of the projects are infrastructure. Sorry, I'm used to that.
No problem.
But what we found with Quadri, okay, it is great. It is actually a design tool also more than a CDE, but it was really complicated to get people into it. I mean, there's a lot of functionality, and we were trying to change the fundamental way in which they work. So we dialed down a little bit and started focusing more on Trimble Connect because, to be honest, it's easier to use. It's more user-friendly. But hopefully in a few years, we will also have an episode in which we can discuss the use of Quadri in Romania. Hopefully.
Years? Are you kidding me? In a few months we can do that, or weeks.
Okay, that would be great. That would be great. Okay, so going back to the CDE, I will be focusing on this current project, the railway project, Vidra Comana. So this is the folder structure we have for this this project. It's a 13-kilometer railway project. These are the members of the projects. I also have, you are also here, or no, you're not here. No. This is from the BIMCon because I have to give them access for the openBIM awards. And we have a lot of people, like something around 40-something people, which are some of them active, some of them not. They're using it, but to be honest, not everybody on site is using it. Currently, some particular people are feeding the information within the CDE and then sharing it with other people. So at first, how we wanted to go about this, I thought that we can take one bridge from this project, a 1.3 kilometer bridge, and BIMificate it, let's say, within the common data environment. As I said previously, in Romania, receiving IFCs or 3D models from the designers is not very common. We know that. But for this project, I was in discussions with the people, the designers for the bridges, and they actually provided all of the models for the bridges. But there was no information attached or something. It was only the 3D geometry, which for our purposes was enough because I wanted to approach this as a pilot project. So what did we do? So we had the model. This is a combination of several 3D models, also the 3D text and the earthworks and so on and so forth, and the bridge from the designers, also the steel from the design.
One question before you go further. Is this text in an IFC format, or you appended it, you added it in Trimble Connect as different elements?
The 3D text?
Yeah, the text and everything, yeah, the extra stuff that you said, or everything is part of a IFC model?
I would say there are more IFC models here. So basically we had an IFC model that was the concrete works of the bridge, let's say. We had another IFC which was the steel, but it was not in coordinates, in real world coordinates. So I had to put it in coordinates in Trimble Connect.
Okay.
The 3D text is created by me in Civil 3D using Dynamo. So that's another IFC model, and the earthworks are another IFC model. So in this particular view, you are seeing 4 IFC models combined in Trimble Connect.
Okay.
Okay, this would be the part of the geometry. And what did we do? So more or less, we had to get a guy on site. So a colleague of mine, also named Petru, by the way.
Hi, Petru.
he is on site. He's working at the technical office on site. And one of his parts on site is to feed feed information to this 3D model. So what does that mean? If I go on every geometry that represents the bridge, every concrete, every pile, every elevation, every anything, we have the ones with this pen, let's say icon here, are all property sets defined by us internally for the project. This can also be taken into account level property set, but we can discuss this further. So what we are doing, basically, we are attaching information to the 3D geometry. Information as which would be planned start, planned end, actual start, actual end. Is it done? Is it not done? What type of concrete is being used here? What kind of rebar? And also quantities. We care very much about the timeline and the 4D, let's say, and the quantities. So how much concrete would have been on this foundation based on the design, but what was actually executed? The same for the rebar, the same for the formworks, so on and so forth. And yes, as I said, we've attached this information to basically all of the geometry. Okay.
Your colleague is doing this on his phone on site?
No, he's doing it on the computer. It's easier to modify property sets. He's doing different. He's also using the mobile version of Trimble Connect to attach pictures and other stuff to the geometry. But I will get back to this.
Okay.
Okay. So because he has completed all of the information, what does this now allow us to do? So you could, of course, go and click every individual element to see what's happening, but more usable, really usable workflow would be something like this. So we came up with our own filters here. We can filter the information based on the properties however we want. So basically what you're seeing here, it's asking me, is the object executed? Yes, no, and then what type of object? So having set up everything like this, we can now go very easily and do something along these lines. So what does that mean? Everything that is green is executed, is already built, exactly. And what is with red, it needs to be built. Okay, nice. But we can now go even further. So we can now go on a type of element level and see effectively for every axis of the bridge, when it has been executed and when it started, when it ended, how much volume should have been there, how much volume was actually executed, and information like that. So like this. And working in such a way now allows us very easily to go print and create this kind of report. I mean, this type of workflow, what's happening here basically, for every element of the bridge on site, they already tracked this data. But what was happening? They were having like 50 Excel files, different Excel files that were not linked to one another. And yeah, so somebody was completing one Excel file, somebody another one, and so on and so forth. The information was there. I would say it was scattered all over the physical server. So basically what we are doing, it's not rocket science or something. We are just taking the information that is already available for the people on site and just translating it here in the CDE. I would like to call this a single source of truth, let's say, because that's all we are doing, okay? And honestly, I didn't know at first when we started this pilot project what to expect. But the people on site were really happy when we showed them all of this. So happy, in fact, that they asked me if I can't model the whole railway. Okay, I didn't understand what they mean exactly. So they said everything. Okay, and I tried to model everything based on their request. So this is another view I've created in which, yeah, of course, we still have the big bridge that's here and has the same information I showed you already attached. But I also modeled in Civil 3D the actual earthworks and then split them using Dynamo in intervals of 25 meters and also added all of the bridges. And now the people on site, when they want to see what's happening on site, they use this view. Another thing that they are doing, and this was their idea, they wanted to do this. So they are adding attachments to the 3D models. So meaning what? For example, photos. You can see in the file name the date the photo was taken, and you know that it's corresponding to the geometry. So something like this. That's how that looked on the date of, I don't know, 20 May 24 this year. Other things they are doing. So basically they are actually adding like site dispositions and reports based on, yeah, so this would be some photos taken here, but as I said, they're using it to also store PDFs with I'm not sure the word in English, the report, if it's correct or not. I'm not sure of the English word for that. But yeah, all of this, it was more or less, I started with the bridge. I wanted to prove that this could be done, and I was happy. They after that came to me and said, let's do more, and that was very inspiring, let's say. And I didn't expect that at first, but apparently there actually is a desire from the people on site to actually start using this and working like this, which I found quite amazing. And
that's actually a big challenge, like getting everyone on board to buy when you start using new tools. Why do you think your team is interested? Why would be some reasons behind why they are excited about these new things?
The people on this particular site in the technical department, fortunately, are younger, let's say, than the normal, than some of my colleagues. So they are very prone to 3D, to stuff like that.
New technology.
exactly to new technology. It's easier for them to understand something visually, and I would think that this would be one of the motives.
Yeah, okay, that makes sense.
Another thing that I found on this site, as I said, we had to get a guy specifically to do this. We tried this on different sites with the people already there, and to be honest with you, this approach was easier. We know that we have 1 or 2 people on site, which this is not his only job. As I said, he's in the technical department, but he needs to do this. It takes like 15 minutes every day maximum for him to update the 3D model. But in my opinion, there should be somebody on site designated to do something like this. This is what I found.
The important somebody designated on site to feed in the information captured there. Yeah.
Yes. I would say that this would be a correct approach. Okay, more or less this was what I wanted to show you guys with the railway project. And now let's get into more complicated stuff. Okay, what you are seeing here, this is a 10-kilometer motorway project that is in the design phase currently. And we will be starting work here next year. And based on the success of the railway project, I and my colleagues all agreed that we will be implementing something similar, adding attributes to the geometry for the whole motorway. So not only one bridge, but everything on the motorway. So as I said, this is a 10-kilometer motorway, which has 8 or 9 bridges, something like that, a 1.3-kilometer tunnel, which we will also split in, I think, pieces of 8 meters, and to track everything. The good thing here is the discussions with the designers. Based on the discussions with the designers, this will be the first site since I've been at PORR that I've ever seen this, but we will be receiving all of the 3D models from the designers. This is already discussed.
That sounds very good.
It is. How this will go, I'm not sure. My ideal would be to also get together the designers and give them access to Trimble Connect and for them to upload the 3D model. This will be discussed exactly in the following months. Hopefully that will be the approach, but in a future video, Petru, I will tell you exactly how that went. But what I can say for sure is that they will provide the 3D models because it's in the contract.
Okay.
So
that's amazing.
Yeah. I'm very confident that we can do something amazing with this project, and I'm very much looking forward for the tunnel because in Romania, motorway tunnels are a very taboo subject. Designers have been pretty much afraid to create designs for tunnels, but now we have to traverse the Carpathian Mountains, so unfortunately we don't have any other options.
No choice.
Exactly, no choice, which for me is great because I will get to see how live a tunnel is being built, which also interests me, of course, as a BIM coordinator, but also as a surveyor. It will be very interesting to see the approach. So I will keep you guys updated with this project. I'm very confident that we can do something amazing here.
When will this project start? When you will start building actually this project?
The design phase ends in June 2023. So 1st of
Next
July,
year.
yes, 1st of July 2023, we enter the execution phase.
Okay, sounds good.
The most likely scenario, we will start at the start of the year, I don't know, maybe February, March, with the site organization stuff. And then move on in the summertime to actually go in the execution of the actual motorway.
And when is this project scheduled to be finished?
So it was, I think the execution time is 3 years or 3.5 years. I'm not 100%, but 3 years or 3.5 years. So 2024, 2025, something like that.
That sounds good.
Yeah, I'm very looking forward to it. Oh, another thing I will be receiving here from the designers, I will be receiving the geological model, or the stratum. This is only for the tunnel, but we will be having all of the layers under the ground as 3D objects. That's another thing I'm quite curious to see how we can use that. But it's something new and it's something interesting.
Yeah, sure.
As I said, I'll get back to this when I have more information, hopefully next year. Another use case we are using, in Trimble Connect. This is for a port expansion project we have here in Romania. We can actually do clash detection within the Trimble Connect environment, which has been very helpful for us because in this particular project, we have like something around 200 electrical manholes or whatever you want to call them, and a lot of pipes under the port. So this has really helped my colleagues on the project to see exactly what's happening. It's one thing to see clash detection, let's say in a 2D environment, which a line does not have a width, a real width, and it's another thing to see it in 3D. So this was also because of the particularity of this project with a lot of utilities, it was really, really helpful for us. Okay.
That's very cool that you could use actually Trimble Connect. Yeah, it's quite interesting that can be used also for clash detection, although it's not as advanced as other tools, but it's cool that you can do it in the same tool.
Yeah, it's helpful because you can do it, as you said, in the same tool in a browser. So yeah, you don't have to install stuff, new stuff. It's been quite useful. The idea is to try to not use 1 million different software, and this allows us to work more, compact, let's say. Another weird, I think, use case, something you don't see very much about, for Trimble Connect would be this. Okay, so visualization is one thing, but what I did here in this view, we actually had at one point, my department, we had a presentation for the whole company regarding 3D paving. So taking the 3D models and putting them in the paver and also in the total station to be able to pave without sticks on site. So what I did in Trimble Connect, I got some 3D models from 3D warehouse of total stations and pavers, and during the presentation I would explain to them exactly what's happening. So something like this: the total station is giving the coordinates to the paver, and then it moves 100 meters, and then it takes the the coordinates from this total station, so on and so forth. And people actually came to me after the presentation and were very pleased because it was much easier to understand this in a visual way. This would be a little bit...
Yeah, you cut out a lot of confusions when you do this.
Yeah, it's one thing to talk, to tell stories, but people, if they see something with their own eyes, it's much easier for everybody.
A picture is worth 1,000 words, right? They say.
Exactly.
So that's very true. We are beasts that can learn very quickly visually. Yeah, it's much more easier to understand things visually. Yeah,
I agree, and a lot of people have told me exactly this expression, that a photo is worth 1,000 words. Okay, to step back a little bit now from Trimble Connect, when the innovation department started in Romania, one of the biggest focuses and use case, you could call it, of a BIM approach to a project was machine control. So taking the 3D models and putting them into machines. Normally, this is not something new. In Romania, in most major infrastructure projects, this is more or less everybody uses this. But what's happening? So somebody is creating the 3D model in software, in Civil 3D, in Trimble Business Center, whatever. They are converting it depending on what type of equipment they have on the machines. They are putting it on a USB stick and going to the machine on site and putting the 3D model into the machine. Okay, that's fine. It works. Of course, it works. I've also worked like this, but we have a little bit of a different approach. So we are linking the Trimble Connect project we have, and that I showed you, to another solution given to us by Trimble called Trimble Works Manager. And what's happening? We are taking the designs that already hold in Trimble Connect and transferring them here. So how would this look exactly? Okay, so this would be a map view for the port site. There is one machine currently in the project, but it's not working. As I said, yesterday was a national holiday, so nobody is working, I'm assuming, today in Romania. So yeah, if somebody was actually on site, this would have been with green, and you can see it in real time how it moves around the site. This is all nice and good, but why? Why is this useful? So we are taking the designs from Trimble Connect and putting them in these new projects here in Works Manager. In this case of the port, it's a platform. It's not very complicated. So yeah, there's one design. Of course, the design changes constantly, and we upload it here, and it automatically updates also in the machine, so you don't have to go again physically with the stick and put it. Imagine if you have 20 machines on site. They don't know what version they're working on. If I have everything, all the machines here, they always know that they are working on the same design. But as I said, this project was a platform. It's not that complicated. But again, going back to the railway project. So the railway project, we had to put into the machines all of these steps, let's say earthwork steps, how they actually dug on site. So how would that look from a machine control point of view? So in this case, we had 3 machines in Works Manager for this site, and we had something along the lines like 80, 90 surfaces, designs. So imagine that this would have been translated in going out with the car to the actual machine and with the USB stick. You can, yeah, I mean, everybody I think can imagine how much time has been
it's necessary for that, yeah.
Exactly, how much time is necessary to do all of these strips. And then you don't know, he's working on that design, he's working on that design. But because all of the machines are connected to the internet, we are just feeding the design here, and the operator of the machine doesn't even know what's happening. He just sees the correct numbers on his board, on his tablet, actually, on the machine. So this was really, really useful for us. Imagine like a situation where you have, I don't know, 50 machines on site, and the design is constantly changes. It's impossible to track, to know which has what design, what's happening. So this was also very, very useful for us.
Yeah, it's a very high probability for errors to happen if you don't have a tool that has revision control.
Exactly. I agree 100%. And the people on site also agree with us. Which is nice. And now to get a little bit, I could talk about different cases for BIM. We use a lot of stuff on our sites. We use augmented reality.
Because we are here in this Works Manager.
Yes.
Does this also eat IFC files as well?
No.
No.
No. What we are pushing here are surface models.
What do you do if you have an IFC model? How do you convert it to this?
If I have an IFC model, I would have to go through a different software like Civil 3D or Trimble Business Center and create a surface out of it. Because the surfaces that are being put in the machines, how can I explain this best? So the actual surface, let's say here for the ballast, the surface itself is only, do you see the red line here?
Yeah.
So the red line connected to the other the yellow line, connected to the other one, and the other one is what represents the surface. What you are seeing here also has depth, see?
Yeah.
So when we are talking about machine control, we are not talking about 3D solids, things that have actual volume. We are talking about a surface, which is a triangulation of sorts. So it has no depth. So if you would receive an IFC, this is actually IFC, what you're seeing here. I would then have to go and manipulate the IFC in such a way to only get the top part of it or the bottom part of it. So it has no volume per se. You can imagine it as a piece of paper. It has no depth. That's what you put into the machine.
Okay, I understand. That makes sense.
As I was saying, pretty different use cases we have on our sites also encompass the AR part, augmented reality. So we use this device called Site Vision and put the designs also in Trimble Connect. And then you can go on site with the Site Vision and see the design in the real world coordinates. And also, we are also doing stuff like this using Unreal Engine. This is more marketing part of it, but we can create using the 3D models stuff like this. So yeah, the gamification, or what you want to call, of the construction industry. By the way, this also works in VR. And I actually did create at one point application using Unreal, in which you can join, different people can join in the same game. Let's say, imagine you're playing Counter-Strike or something. So you can go in the 3D model of the construction site and talk to people using microphones and basically hold a meeting in the future construction site.
Really, really cool stuff.
Yes. We are very enthusiastic, let's say, about new technologies, and we are trying to always trying to find out new ways to use these models. And this is, as I said, very useful for marketing. Colleges, I've been to colleges to present this, and the students were very impressed and never seen anything like this. I mean, to see a game compared to see a 2D
drawing
on paper, it's a little bit mind-blowing for them.
Yeah.
This is where the future is heading us.
It's much more effective, it's funnier, and much more enjoyable to use it. Why not just use it? Why use older stuff and technology, right?
I agree.
I have a question about site vision. How happy are you with the tool? You know you can do stuff with Trimble Connect augmented reality version as well, right?
Yes.
Okay.
Yes. Currently, we are testing for the new Motorway project that I showed you here. I actually had a request for one site manager for me to prepare the surface model of the motorway, and he wants to go on site with a site vision, point it down at the ground and see. We still have to dig 20 meters. We still have to fill 1 meter and to check the execution like that. So requests are being brought to me by the actual people working on site. It's not market gimmick anymore, site vision. They are actually using it.
Couldn't you use Trimble Connect AR for that? Is not enough? What else more does site vision do for you? That
precision.
Precision, because you are using GPS.
You are using a GPS. In the case of Trimble Connect AR, that's useful for, in my opinion, for buildings, where you can orient the model based on QR codes, so on and so forth. If you are in an open field, as infrastructure projects are, it's, in my opinion, easier to work with the GPS. Most likely, we will use Trimble Connect AR for the tunnel, because the GPS doesn't work in the tunnel.
Yeah, that's true. That's true indeed. So there is the use case for site vision, especially for infrastructure, because if it's not tunnel, then you are out in the open and you can get also quite good precision from the GPS. Okay, cool.